Okay, so let's find the deflection, determine the deflection under 60 kilonewton load in the beam as shown in figure by using the strain energy method. So we'll use strain energy method. Okay, by using strain energy method. Now, one thing in the strain energy method, you have to know the strain energy stored in the members. Already I given you the derivations. So all the four derivations are important. Strain energy stored due to the bending, axial load, shear, and the torsion. All the four derivations are important for exam point of view. To solve the problems as of now, for us, the shear strain, the strain energy stored due to bending and the axial is very important. Bending is for solving the problems on beam. Due to the axial is to solve the problems on the trusses. Okay, so in that case you have to remember those two equations. Okay, one is the strain energy stored due to bending and the strain energy stored due to axial forces. Okay, now let's start with that. Now one more thing, the important thing is here, see, by using the strain energy, I'm not going to calculate the slope. That is not possible by using a direct strain energy method, so we need to modify that one. So I'm not going with the modified one, I'm using the straight strain energy. Even if I give the UDL and no point load, so I cannot use the strain energy method. So in that case we need to modify that one. So the strain energy method can be used only to find the deflection under a given load. So very restricted cases here. So strain energy concept can be used to find the deflection only under the given load. If there is no given load, you cannot find the deflections. Okay, now so once there will be three problems, we'll solve it. Okay, it's a very simple problems. Now we'll start this one. So this is the beam I have taken. Okay, now we'll get the reactions here. So if you calculate the reaction, this reaction is 30 kilonewton and reaction at B is 30 kilonewton because it's a symmetrical one. Now first in the strain energy method, you have to get the strain energy. The strain energy due to bending, okay, you write on your strain energy due to bending U is equal to integration 0 to L m square by 2 EI dx. So you have to get the strain energy. Now where I'll say m is mx. The strain energy, to get the strain energy in the beam AB. So what I'll do is I'll split the beam into two parts. One is A to C and B to C. It's not because of EI is changed, it's because of the point load. So you split at the region of the point loads. Now in that case what will happen, the strain energy U is equal to integration, so 0 to 4 mx divided by mx square divided by 2 EI into dx plus integration, so C to B. So if you want you can write in the form of A to B and C to A and all. Okay, I will do one thing, A to C I'll write, and then I'll write B to C because I'm taking A is origin and B is origin. So this is what is mx square by 2 into 2 EI, because 2 is the one and 2 EI is the one more thing, 2 into 2 EI. Okay, this is what you need to do it. Okay, so let's find the mx. So what is the bending moment at any distance x? So you're taking x from here and you're taking x from B. So the bending moment at any distance x, bending moment at a distance x from, say, since symmetrical, so I can say both the things, say A or B, mx is equal to, what is the answer, 30 into x. So it is 30 into x. Okay, that's only the simple thing, we'll get it up here. Okay, now let's do it. So substitute that one, so you will get the total strain energy. So it is 0 to 4 and m square is 30 into x whole square divided by 2ei plus integration 0 to 4, so it is 30 into x whole square divided by 2 into 2ei. Now if you solve it, if you solve these things, you will get it. One is 9600 by ei and plus 4800 by ei. So if you add everything, you will get the answer 14400 by ei. So this is what is the total strain energy. Now in using the, when you use strain energy concept, so we have in one thing, the total strain energy is equal to work done. The total strain energy should be equal to work done, and you can write, we know strain energy, so I'll write E is equal to work done by the external load. So U is equal to half into P into delta. Okay, so this is what is the basic equation you have to remember. So one is strain energy, one is this equation, that's it. Now substitute the values of U here. So 1400 divided by EI should be equal to half into P. P is now 60 into delta. So this is what I want, delta C. So then if you calculate, C is equal to, or delta C is equal to, you will get 480 by EI. This is a simple problem. You can will be solving 2 or 3 problems like this. Thank you.